So, hello there. Today I want to show you a little bit of instant technology, and I love instant technology, I love it. Because you can do stuff like this. But I want to show you the logic gates you can make like this and so on. But first let's talk about this. This is a simple instant repeater, like you can see in the Cyclops server or on other servers too. On ours, not really, because we're in a version called 1.14, and that version is a little bit dumb because of chunk loading. But you can still make these instant repeaters, of course. Why instant repeaters? Because look at this. These, no one of them will retract the other one. Because if you would have a repeater in between, I think I hope that I don't say anything wrong right here. Would have a repeater in between, like an actual repeater. No, I was wrong. Okay. Yeah, I was wrong. Okay, I thought. Yeah. Wow. What would be interesting to know if testing again. Yeah, of course. Because this one gets active first. But this is the only part I wanted to show you. You can also make gates with that, like these here. So-called not gate. And you can see that this is instant because these are retracting and extending. Good. But then there's something else, which is an OR gate. And you can see that this really doesn't do anything if I change anything here, but if I turn any one of these on, this will accept. Then we have so-called NAND, because this signal is off if both of these are on. Normally you use this system, where when both of these are on, this thing will turn on. And yeah, this is because you put these blocks here with an instant repeater technology. Exactly. And these are the main four logic gates, like NOT, OR, AND. And you can connect these to stuff like this. Like for lamps, because you may have noticed if you have a few levers right here, turn one on, the light goes on. Like if it's the redstone lamp, in this case, you turn it on. If another one is on, it gets off. Other one is on, off, and so on. So always when you change one thing, the result changes. And you could do it with this system right here. It's just this repeater is OR gate right here from input A and input B, and NAND gate right here. So we have an OR and a NAND gate. And both of these are going into a NAND gate, which gets put into a AND gate, and then our output is this. You can also make this with real redstone stuff. I can hopefully show it to you. Like if you have this, or like do it like this. And what we're doing here is, can we have, oh man, it's difficult. I have no clue what I'm doing here. I'm just trying to improvise a little bit. But it's an XOR, isn't it? Okay, then we can make this simple system. Which I'm still struggling with to sometimes remember. Really redstone heavy thing. Yes, I need this. Oh, no. You can have like something like this or something. I have no clue. But this thing has delay. That's a big problem with it. As you can see, this takes a while until it turns on. Here it's instant, which is great. Okay, that's like everything I can show you. But I've once experienced this stuff by myself. If I go over here, you can see a really interesting thing. There's an adder, so-called adder, a full adder, and this full adder can actually add numbers. But this thing is designed by Pi, and I don't want to really say anything about it because it's his design, and I've done some things with it and experienced some stupid stuff that I've never ever before encountered. Here, this is a 4-bit multiplier which isn't working. An instant multiplier which should multiply numbers instantly, which it doesn't because it's not correct. What do I mean by that? It's pretty simple. What I mean by that, because there are tile ticks. So in a tick there are many ticks, and without that this here wouldn't be possible. What I mean by that, I can demonstrate it. Or can I? I think I can. If we have the same signal going on or going into two of these with that and that and this, and this is a NOT gate with a lever, and here we don't have NOT gate. And both of these are pointing into the same piston. Then this piston actually doesn't activate here. Okay, I'm dumb. Ah, now I know why. Wow. Of course it can't function like this. I'm dumb. Sometimes. Because we need to make a difference. Here there wasn't any difference, this will work fine. That's the thing. You need to that's really important. You need to remove all the tile ticks. No, all the tile tick differences, I need to say. Now this thing would flicker. There you saw it. That's not good. That's not good at all, because this piston is actually recognizing a change, a tile tick difference, because this thing is ending first. Okay. Good, I think that was everything I wanted to show you, but of course I actually test around with it a little bit more and how you can get around this tile tick issue. Here you can see a rather big thing. This should later be a multiplier, but I really never got around doing it because it's really difficult. And this is only, I don't know what one was it. How many bits was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 bits by, yeah, 16 by 16 bits. So not actually that much, but this thing is ginormous. This is the multiplying part, and later there would be adders across this whole distance. And that would be really dumb because, as you could see, these adders are huge, huge, humongous. But this part is already done. So like you can multiply here. It's possible. But I will no longer work on this because I want to get not the instant stuff. Of course you can make the lines that go to their corresponding things instant, but these lines are a lot larger. And with a lot larger I mean actually quite a lot larger, as you can see. This wouldn't be too much worse. So of course you could move these together really closely. It would be about double space efficient and you don't need to go up. But it would still be a bit big. A bit. Just a bit. But yeah, this is what I wanted to do. But I realized that this is too much effort to do. Really a lot too much. Okay. I hope this video was informative for you and you could learn some stuff out of this. So let's end this video right here with this great view of a 16-bit multiplier. Yay! Bye.